Hey, Assalamualaikum warahmatullahi wabarakatuh. Good morning to all my students. Okay, so class, if you realize that we are actually have done, recall, almost at the end of our end of the semesters. This is the last final chapter or final, the last final lecture for this semesters, meaning that this is the ending of our a lecture for the whole semesters of matriculation. Topic 10, specifically 10.4, distribution approximation, meaning that after this I'm going to say goodbye to all of you and wish all of you good luck for the final examination. And I do hope that, I do believe that all of you, okay, will try harder, smart, and also get the result in flying colors. Okay, so without wasting so much time. Okay. So then the objective of this, okay, we're going to look into the situation where we are going to use the normal distribution to approximate the binomial distribution. So in in the easy way to explain this, let's say the question there's a question of binomial distributed with the number of trial, the parameter of n, and also p, the probability of success. We use the binomial, not binomial, okay. Then we use the normally distributed with the parameter of mean and variance. Okay, so approximation from binomial to normal. So this is the question, and this is the distribution that we're going to use to find the answer, not binomial. Binomial is just question that the situation given to us, but we are going to use the normal. Okay, when n is greater than 50, when p in between 0.1 until 0.9, and the multiplication of these two numbers is greater than or equal to 5. And the parameters you can see here, mean with the n, number of trial multiplied with probability of success, and variance equal to n multiplied with p multiplied with q, which is the probability of failure. Okay. And since that the binomial apply to discrete random variables, okay, so this is the key thing here, discrete, whereas the normal distribution applies to continuous random variable. Okay, so from these two different cases here, from discrete to continuous, so we need to make some correction for continuity. So that's what we call the continuity correction. Class before that, okay, please, okay, look at this book. Okay, I think that we believe that all of you have this book then. Okay, statistical table. Turn to page 1. Turn to page 1 and please read from this paragraph and this paragraph. Okay, so then similarly for n greater than 50 and either p less than 0.1, or then this type of pair of n and p, the Poisson, this, okay. This explained to you where two cases of we call discrete, which is binomial and Poisson, can we transform into the normal distribution to find the answers, and of course we need to make some correction for continuity. Okay, meaning that according to this one, okay, Poisson distribution and normal can be, okay, for similar of this, from binomial to Poisson and normal approximation. Okay, you read by yourself here to understand that. And also, turn to page 10. Okay, turn to page 10 and refer to this paragraph here. Table 2 shows the probability values for parameter values of lambda, for lambda equal to 30 only. For lambda that greater than 30, Poisson can be approximated to the normal distribution. Okay, with the parameter of lambda, mean is lambda, and also variance is also equal to lambda. Meaning, not just for binomial that we can use the transform into the normal, but also for Poisson. But for this we call in this syllabus for this time, we're going to just look at we call a situation where from binomial that we use the normal, okay, to solve the questions there. Okay, never mind with the racing. Make it short. We call short and make it shorter. Then we'll try to look at the all this thing. Okay. With the examples, it makes me call all of you clear what I'm trying to say to all of you then. Okay, since we have greater than a minus and a plus, so what is all this then? Okay, now just look at this all first. Okay. Example. Okay, so then just imagine that for this x, okay, x greater than or equal to 4. From this number line, you can see that the value of x greater than equal to 4, it moved to the right side here, okay, including 4, okay. So before we move to the right, we take a 0.5 minus 0.5 step behind before we move to the right here, okay. Because it's including 4 here, then this is probability of x greater than or equal to, okay, greater than 4. Before we move forward here then, okay, just imagine that there is a person, okay, for going to the right side here, moving forward here, so it needs to take a step of 0.5 behind, okay, 0.5 step behind, so you just imagine that it is 3.5, okay. Okay, class, I think that you're going to write this way here. 4 minus 0.5, okay, it is x less, okay, or not. X greater than 3.5. 4 minus 0.5 equal to 3.5. For x greater than 4. Okay. For question A just now, we try to find the probability for x greater than or equal to 4. Okay. For this question of B, goes to the same direction to the right, but the difference is this time it does not include 4, meaning the numbers, the round figure that we call after the 4, meaning is begin with 5. So same direction to the right, but this time this does not include 4, so we take 0.5 step to the right and straightly then continue to the right side here then. So this is probability of x greater than 4 plus 0.5. Okay, so it is probability of x greater than 4.5. Anyway, we take a look at all this explanation first before we before I explain to you where that we're going to use all this 4 plus 0.5 minus 0.5 in the real situation then, okay? Okay, what about this one here now? 4, okay, less than or equal. Okay, just now we looked into the situation, into the question where x greater than or equal to 4, so direction to the right. Now look at what we call the situation where it's direction to the left. And this time it is included 4. Okay, before we move to the left side, then we take a 0.5 steps. Okay, take a 0.5 step behind, we call behind, or in this situation it's to the right, then we move to the left. Okay, so then it is probability of x less than 4 plus 0.5. Then it is probability of x less than 4.5. Okay. Next, what about this one here now? Okay, the same direction to the left, just like this. Okay, the difference here now is it does not include 4, meaning 4 is not the starting point of the recall for this x less than 4. Okay, meaning that it begin with 3. The real figure, the number round figure for beginning here is 3. So since that is recall less than 4, so then we take a 0.5 step to the left, then we continue the journey to the left hand here for x less than 4. So for this time here now, it is 4 minus 0.5, and it is x less than 3.5. Okay, and what about this one here now? For 4 here, then case static where x exactly equal to 4, then we add a plus or minus negative 0.5 here and 0.5 here. Okay, so probability of x in between 4 minus 0.5, 3.5, and 4 plus 0.5, 4.5. Okay. Okay, now between 4 and 8. Okay, x lies in between greater than or equal and less than or equal, meaning okay, so it included 4 here. So before we move to the right, to the right of this 4 here, we take 0.5 step to the left. And for this one, which x less than 4, less than 8. So does it include with 8 here, then we add with 0.5 to the right. Okay. So then this is x 4 minus 0.5, 3.5, and 8 plus 0.5, then 8.5. And what about this one here now? 4 and 8, x greater than 4, x less than 8. Okay. Just now, we look into the situation where we call the question where x is less greater than or equal and x less than or equal. Now, the difference now here is this does not include 4 and does not include 8, meaning from the we call the number line, it instead started with 5, 6, and 7. Okay, so for this one here, because does not include 4, then we move 0.5 unit to the right, and since this also does not include 8, so we minus 0.5 to the left. Okay, So now it become 4 minus 0.5 and 8 minus 0.5. 4 minus 0.5, 3.5, 8 minus 0.5, 7.5. Okay. Now we look into the question where just one side with equal sign, another side without equal sign. Okay, including 4 and does not include 8. 4 and 8. Okay, so let's begin with 4 here now. 4 is part of it. 4 is what we call x equal to 4. So then we take 0.5 step to the left, then we move to the right. And since that this does not include with 8, okay, if this include with 8 here, then we add up with 0.5, but this not. So then we minus 0.5 with 8 here. So then property of x 4 minus 0.5 and 8 minus 0.5. It is 3.5 and 7.5. Okay. This one for 8. Okay. X does not include 4. Okay, it's just x greater than 4. So then we add up with 0.5 here. Okay. And this one, it is included with 8. So then we add up with 0.5 here. So then it is 4 plus 0.5 and 8 plus 0.5 equal to x 4 plus 0.5, 5.5, and this one is 8.5. Okay. Write down each of the probability after continuity correction. So then x less than or equal to 5. Include 5, so means that 5 is one of the answers that here. For this x less than or equal, so we add up with 0.5 here, which is probability of x 5 plus 0.5, 5.5. And this one 8, x greater than 8. Since that this does not include with 8, okay, it begins with 9 here. So we take 0.5 step to the right. Okay, so it's come out with x greater than 8.5. And this one 10, x less than 10. Just now is begin with we call equal to 5, so we take 0.5 step to the right. And for this one, it does not include with 10. So we take 0.5 step to the left. So it is probability of x less than 10 minus 0.5, 9.5. And this is x greater than or equal to 125. So that just now is does not include 8. So we take 0.5 step to the right. But this time here now is including 125. So we take 0.5 step to the left. Okay. So we begin x greater than 124.5. Next one here. Greater than or equal to x 3 and less than or equal to 9. So since that both equal for this time here now, we add up with 0, we call extra of 0.5 to the left and extra 0.5 to the right. So this one here now, it becomes 3 minus 0.5, 2.5, and 9 plus 9.5, 9.5. 2 and 7. Okay. So this time here now included 2. So we take extra step to the left, minus 0.5. And this one here does not include 7. So we less or minus 0.5 here. Okay. 2 minus 0.5, 1.5. And 7 minus 0.5. 6.5. Zero and 4. Okay, so this does not include 0 here, so then we take 0.5 step to the left, to the right, and this does not include 4, so we call less than 0.5 here. So then x lies in between 0.5 and 4 minus 0.5, 3.5. Okay, and this one here we just add up with 32 minus 0.5, which is 31.5, and here 32.5. So now we continue with example here. Okay, so let x binomial distributed with number of trial is 200 and probability of success is 0.3. Use the normal approximation to find, okay, all this one here now. 200 at 0.3, x binomially distributed with, okay, just now is 200, sorry. Okay, 200 and 0.3. So we transform into a normally distributed here with n, I call the parameter of mean with n number of trial multiplied with p 0.3. Okay. Okay, so then 200 multiplied with 0.3 equal to 60. And multiplied with 0.7 equal to 42. So x normally distributed with mean and variance. Okay. So don't forget that this is a parameter for mean and this is for variance. Okay, now the first question then, a probability of x less than or equal to 50. Okay, so it is now equal to probability of x. Okay, x less than 50 equal to 50. Less than or equal to 50. Okay, so since that is equal to 50 here, so we take extra step 0.5 to the right. Okay, so it is now x less than 50.5. 50 plus 0.5, 50.5. Okay, the first step here now, we are taking a step for continuity correction. Since that is from binomial of discrete to normal for cases of continuous, so we take the first step here now is to make a continuity correction plus or minus with 0.5. For this case here now, it is plus 0.5. So from this x, we go into the standard of normal distribution here. Okay, so 50.5 minus mean 60. Okay, divide by standard deviation. This is variance and standard deviation is square root of 42. Okay, so first we take a step of continuity correction. From x less than or equal to 50, it became equal including 50 here, so we take extra step plus with 0.5, so then x less than 50.5. Second step is to use the formula from x by binomial to standard of normal distribution with x minus with mean divided by standard deviation. So these two parameters that we can refer to this x with the mean and variance, where mean is the multiplication of number of trial 200 multiplied with 0.3, and variance is we call multiplication of the number of trial multiplied with p and multiplied with q, where q is 0.7. Okay, so let's find out this one here now. 50.5 minus 60 and divide by square root of 42. Okay, this one here now. Okay, as you can see, equal to negative, okay, you can see on the screen here now, negative 1.46 less than negative 1.46 and negative 1.46588, so 1466. Okay, so class, okay, and negative 1.466 somewhere around here, negative 1.466 less than, so we transform this to the right side. Okay, just imagine that we transform this here, 1.466. Okay, why? Because we are going to find the probability from these tables, and the probabilities, we call the result of this, probabilities of this can be only found out for the cases of z greater than or equal to something. Okay, not for less than. So for this one here now, table of standard normal distribution 1.46. Okay, well, because it's 1. For this book, it just gave you reading until 1.2 decimal places. So this is 1.47. Okay, let's find out now. Okay, 1.4. Find out from z here till you reach 1.4, and then 1.4 plus 0.07. 0.0708. Okay, again 1.47. For 1.47, so we find out we call the result of z, which is 1.4 plus 0.07. So z 1.4, and find out result of 0.07 from here. So the intersection between these two is 0.0708. So it is 0.0708. There you go. The next question then, B, probability of x greater than 60. X greater than 60. So direction to the right, and it does not include 60, so we take 0.5 step for we go to the right, just like this one here. It is probability of x greater than 60 plus 0.5, 60.5. Okay, just now we transform into the normal distribution with 60 and 42, from binomial to normal of 60 and 42. Okay, so then probability of standard normal distribution Z greater than 60.5 minus the mean 60 divided by standard deviation, which is square root of 42. This is variance and this is standard deviation. Okay, what we get then? For this one here, again, 60.5 minus 60 divided by square root of 42. Okay, I do hope that all of you can see. So, this one here, and equal to 0.07 something there. Okay, 0.0771. Make it as an 0.077. Okay, we can just find out the answers from here with 2 decimal places. So we make this as an 0.08. Okay, so from reading from this book here, it is from 0.0 plus 0.08. This is the Z, and this is from the top of the table. Okay, 0.0 here on the top. Okay, and intersect with match with 0.08, 0.08. There you go. Then it is 0.484681. It is 0.4681. Okay, now for C, okay, probability of X greater than 36 and less than equal to 54. Okay, so it is between 36 and 54 equal, so we add up extra here with 0.5 and also extra here 54.5. Okay, so probability of X, 36 minus 0.5, 35.5, and also 54 plus 0.5, 54.5. So transform this from X into standard of normal distribution. Set 35.5 minus 60 divided by, this is variance, or divided by standard deviation. And also here 54.5 minus 60 divided by standard deviation. Okay, so press the calculator, and this again give you negative 3.78 and also negative 0.85. Okay, we use the graph, or we call the normal graph. Okay, sorry for that. Okay, there you go. Okay, so now negative 3.78, somewhere around here, negative 3.78, and this is negative 0.85. Okay, so class, just imagine that if this area we bring up to the other side, sorry for not proper, okay, not really smooth and nice graph here. Okay, there you go. So negative 0.85 we bring up to the side is 0.85, and negative 3.78 we bring up here, which is 3.78. Okay, from this statistical book we can only find we call the probabilities for z greater than or equal. Okay, so class, this is probability of z, okay, greater than 0.85 minus, okay, greater than 0.85 minus the result of greater than 3.78. So z greater than 0.85 minus probability of z greater than 3.78. Okay, so 0.85, again, please refer to the page of 21, standard table of standard normal distribution. 0.85, okay, find out 0.8 here, and then match with 0.05, so it is 0.1977. 0.1977 minus, okay, 3.78. 3.78 down here. Okay, 3.78 down here, and match with 0.08, which is 0.00008. Okay, 0.001234008. Okay, so these two minus up and you get 0.1969. Next question, C, D. What about D? Okay, what's the question of D just now? D between 52 and 59. Probability of X in between 52 and 59. Okay, so from this, we call number line from 52 until 59. Okay, so this does not include 52. So we take 0.5 step to the right, we call forward to the right. And this does not include with 59. So we take 0.5 backward here. Then X 52 plus 0.5, then it come out 52.5, and 59 minus 0.5, it gives you 58.5. Now, the first step is continuity correction, clear. Then turn it into from binomial to normal, which is 52.5 minus 60 divided by square root, we call standard deviation, square root of 42. And also 58.5 minus 60 divided by standard deviation of 42 here. Okay, and this gives you Z in between negative 1.16 and here is negative 0.23. Again, both of these result left negative and negative. So from the graph is of course both are on the left side. Sorry. Okay. Okay, now negative 1.16 and here is negative 0.23. Okay, so we bring this to the other side. Sorry. Okay, now here is 0.23 and here is 1.16. So class, we can only find the result of this by finding the probability of z greater than 0.23 minus probability of z greater than 1.16. So then it is probability of z greater than 0.23 minus probability of z greater than 1.16. Okay. 0.23. Okay, from here, from this book, 0.2 plus with 0.03, 0.2 plus 0.03, 0.4090. Okay, the result of this is 0.4090 minus 1.16. Okay, 1.1 and then 0.06 here. Okay, 1.1 with 0.06, 0.1230. Okay, it gives us 0.1230. That is equal to 0.2850. Okay, and next one, E. Probability of X and 66 greater than less than equal to 76. Okay. 66 and 76 greater than less than or equal. Okay, so does not include 66. We will take a step of 0.5 forward or to the right, and this one here including 76, so we take 0.5 step to the right. So then it is X 66 plus 0.5, 66.5, and this one 76.5. Okay, and take the step of this, and this one we're going to give you 1.00 and 2.55. Okay, I straightly gave the answer for according to my notes here. And now, from this, let's sketch the graph. It is 1, here 1.00 and 2.55, 2.55. So it is a probability of greater than 1, okay, z greater than 1.00 minus probability of z greater than 2.55. Okay, so then 1.00, 1.0 plus 0.00, and it is give you 0.1587, 0.1587 minus 2.5, 2.5 plus with 0.05, it is 0.00539. Okay. 0.00539 equal to 0.1533. Okay, class, for question F, here, sorry. Okay, I have no idea what's happened here now, but then let's continue with the equation F. Okay, I continue with the equation F here. Okay, equation F, where it is probability of X equal to 70. And this one here, it is X, okay, 70. So we add up minus 0.5, and now with 0.5, it is 69.5. No, not equal sign here. And also 70 plus 0.5, come out with 70.5. Okay, now turn into Z. And this one give you, okay, 69.5 minus 60 divided by square root of 42, 17.5 minus 60 divided by square root of 42, it gives you 1.47, 1.47, and 1.62. Okay, yes, that's it. Okay, because is normal with 60 and variance is 42. Okay, 69.5 minus 60. Okay, so then class, for this one, (1.47) and 1.62. So we find that we call the probabilities which is greater than this minus the probability of greater than this. Greater than 1.47 minus probability of Z greater than 1.62. And this one from the book give you, okay, let's find out yourself then. 1.4 and 7. 1.4 and 0.07, 0.0708, 0.0708 minus 1.6, 1.6 with 0.02, 0.05 to 6, okay, 0.05 to 6 equal to, okay, 0.0708 minus 0.0526, 0.0182. Okay. Example 4. Okay. A fair coin is tossed 400 times by probability of getting less than 230 tails. So it's a X with binomial distributed with number of trial is 400 times. And what is the probability of success? B. A fair coin. I think that you know how coins looks like. Okay, coins of 20 cents, 50 cents. There are two faces, whether head or tail. Okay, so the probability of success is 0.5, B is 0.5, and also Q 0.5. Okay, and since that the number of trial is greater than 50, so we are going to transform into a normally distributed with number of, we call parameter of mean, 400 times 0.5 equal to 200. And then the parameter of variance, 400 times 0.5 equal to 200, and 200 times 0.5, 100. Okay, the normal approximation there. So, we call the property of with x less than 230 tails. So then it is x less than 230 less than. So does not include with 230, so we minus 0.5, we come out with 229.5. Okay, so z less than 229.5 minus 200 divided by, this is variance, so standard deviation square of 100 to 10. Okay, then this is 2.95. So 2.95 2.95 less than 2.95 okay, the total area between the curve and the x-axis is equal to 1. Okay, 0.5 to the left side and 0.5, half and half, 0.5. But now it is less than 2.95. So according to the picture here, it is cross the half of the left side here, including this part here now. So we come out with 1 minus property of z greater than 2.95. So class, let's find out this one here now. Z greater than 2.95. Okay. Here is 2.9. Okay, 2.9 and mesh with 0.05. So 2.9 here equal to 0.00159. 0.00159. No. Then equal to, okay, for this one here, make a recall simple. 1 minus 0.00159 equal to 0.99841. Okay, and then between 180 and 190. Class, for this one here, for question of B, property of x greater than between 180 and 190. Okay, so come up with z here, 180 minus 200 divided by square root of 100, which is equal to 10, and 190 minus 200 divided by 10. This gives you negative 1.95 and negative 1.05. Class, I think that because this is the last final example, I have gave you a few examples previously. Try to get this, and I gave you the final answer. Try to find out using the graph, and then find using from this table, from this book, and the final answer for this is 0.1213. Okay, find it yourself. Try. Okay, so class, this is the end of our discussion and lecture for this semester. So I wish all of you good luck, try your best, never give up, and that's all for today. Thank you very much. We'll meet again next time. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.